Hi everyone, this is Ken 121, week number 6, and this week we will talk about plotting in Python. So how to generate figures, how to represent data graphically, specifically using plots, which is something you would use a lot throughout your studies and throughout your career. So we have an in-class exercise which we will go through during this video, and then you have two exercises to do as a homework, and they are basically a replica of what we're going to do in class, just using different numbers. So let's get started. Let's have a look here. So you're given the following set of experimental data, which was measured in a reactor for the concentration of a certain chemical or a certain species A versus time. So you have time in minutes, 0, 50, 100, all the way to 300. And then you have concentration in moles per decimeter cubed, 0.05 all the way to 0.0174. So what you're being asked is, using Python, not MATLAB, right? Using Python, write a script to generate 4 plots of Ca versus T, so concentration versus time, Ca squared versus T, concentration squared versus time, ln Ca versus T, and 1 over Ca versus T. And then you want to present the plots side by side in a 2x2 figure. Clearly label your axis and provide a title for each plot. Okay, so let's move on to Python, and let's go over this exercise, how to generate these three different data sets, which are derived from the original data set. So we have concentration, we need to generate concentration squared, we need to generate ln of the concentration, and ln is basically the natural logarithm, and we need to generate 1 over Ca of this concentration, and then we're going to plot all of them on the same figure. Okay, so let me move on to Python, and this is Spider here, and first thing I'm going to do is I'm going to just paste the problem statement just so that we can see it in front of us. And this should be it for now. Okay, so when starting a code, when starting a new script in Python, the first thing we need to do is to import the libraries, right? So here we're going to start off by importing the libraries. And what this means is that, as we said before, in Python is just a language. However, there are certain libraries you need to bring in so that you're able to do some mathematics or generate some figures, etc. And this is what we need to do at this stage. So the first library we're going to import is Numpy, which we mentioned before. So import Numpy as NP. And Numpy is a library which allows you to do, it's called numerical Python, allows you to do numerical manipulations and numerical calculations in Python. And the structure here is the word, let me zoom in here a bit, maybe this is better. The structure here is import is the active word, Numpy is the library, as NP. NP is sort of the abbreviation you're going to use in your code. So in the rest of the script, when I want to call Numpy, I can just use the letters NP to call the library Numpy. The second library we need to import is pandas. So we're going to say import pandas as PD. And so this is numerical Python. This is for math, basically. Pandas is allows you to deal with data sets and lists, and do manipulate data sets and manipulate lists, etc. And it's also useful to have it when trying to generate figures and similar graphical representation. And the third library we're going to import is called pyplot. So we're going to import matplotlib dot pyplot as plt. And what this does is this allows you to generate plots. As you can see, pyplot is basically Python plot, right? Generate plots. Okay, so now we have our three libraries imported. So next step would be, let's um, create the two lists for the input, right? Input lists. So in this case, we have some list of time. And again, to generate a list, we just have our square brackets. And I'm just going to put in the data we have, which is 0 to 300 with increments of 50, right? So I'm going to have 0, 50, 100, 150, 200, 250, 300, right? 1, 2, 3, 4, 5, 6, 7. You need to just verify. Good. And then the next list we're going to generate is the concentration. I'm going to call them T and CA. And let's just add a comment, time in minutes. And this will be concentration, concentration and mole per decimeter cubed. And let's put in the data for the concentration. Again, I'm going to create the two square brackets and I'm going to put my numbers between them. So in this case, they are 0.05, then 0.038, then 0.0306, 0.0256, 256, 0.0222, 0.0195, and finally 0.0174. So this is my concentration and my time. I have the two lists generated. And before generating these data, let's test out this plot function, or let's test out this pyplot function here, and let's see how we can use it actually. So in order to generate a plot, this is the general structure. You call the plot library, which is plt, and then dot, and then you put in the plot command, right? plt.plot, and then I'm gonna open a set of brackets, and in the set of brackets, first thing I'm gonna put is the x data, in this case it's time. Second set I'm gonna put is the y data, and it's ca, right? So plt.plot t, comma, ca. And if I run this, or if I run this script, I should see a figure here with time versus concentration. Let's give it a try. And you will see, you have time here and you have concentration here. Of course, this is not a good way to present the figure. You have no labels, either it doesn't tell you any information, you have no idea what is being shown on this figure, right? So in this case, you usually want to add a bunch of other things. The most common things is your x-axis label and your y-axis label. So in order to add an x-axis label, you just add plot.x label, and then you open your brackets, and then you have a you open your single parentheses at the top, and then you put in your x-axis label. So in this case, it will be time in minutes. Similarly for the y-axis, again, I call the plot function plt. I put in the command y label, and in this case, I have the y axis label, concentration, and we said it's in mole per decimeter cubed. So in this case, if I run the script in this format, let's give it a try. I'm gonna get to see concentration and time. So this has a bit more information. If you want to add a title to your figure, you put plt, you call the plt library, then you put the command title, open your brackets, and then we're gonna give it a title, in this case, time, or maybe concentration versus time, right? And now if I run it, I should be able to see the title show up at the top here as well, concentration versus time. So these are basically your basic commands for plotting. You can do many things. So if you look on the manual, or if you look online, you can do many manipulations to graphically make it look better. So for example, let's say I want to change the color of this line from blue to green. Let's say you're not happy with green. So I'm gonna add a third command in the plot here. I'm gonna say G. Let's call it G. Let's give it a try. It changes the color to green. You can change it to red if you want. You can change it to like a vibrant blue, a yellow. There are many colors which you could use for this case, right? I think orange also works. No, so when I put O, it changes it into spheres. Then I guess if I put X, it will change them into small x's. If you put, let's say, a plus, it will make them into plus signs. You can see you can make many manipulations, or many sort of graphical things. So if I put a color, let's say I put B plus, in this case, I'm gonna get vibrant blue with plus. Maybe it's not very visible here. Let's say call it red plus. You can see you're gonna get red plus signs or red circles, whatever it is. So you can use this third space here to really make your figure look different. You know, especially for presenting multiple lines, ideally you want them to have different colors. Okay, so this is the basic plot command. So now let's go back to our problem. So our problem says using Python, write a script to generate 4 plots of CA versus T, CA squared versus T, ln CA versus T, and 1 over CA versus T. So let's first of all generate these 4 lists, and then we're going to generate 4 plots and put them as subplots into one main figure. Okay, so in order to generate these 4 lists, let's so here we're gonna generate the, I guess, the 3 other lists. Generate the lists CA squared, ln CA, and 1 over CA. So in order to do this, the logic I'm going to use is that I'm going to run a loop over the concentration over this list, and with every increment of the loop, I'm going to calculate these 3 values and then add them to these lists. So what the logic will be, I'm going to run a loop over the list CA, and then with every loop increment, I will calculate, let me smooth this, and then with every loop increment here, I will calculate the values for CA squared, ln CA, and 1 over CA. Good. So let's do this. So first thing we need to do is we need to initialize these lists, right? Because you can't really put a list in a loop without initializing it. So let's initialize it. So I'm going to call this CA squared, CA underscore SQ, and just going to put the empty brackets here, and this is list for CA squared. Similarly, I'm going to call it ln CA equals this, and this will be the list for ln CA, and then last one will be 1 over CA, and this will be list for 1 over CA. Good, so I have my 3 lists initialized. So now what I'm going to do is I'm going to generate or add the numbers to them. So again, in this case, I'm going to use a for loop. So if you recall, I'm going to say for I in CA. So what this does basically is it will loop over all the values in this list CA, and I'm just going to calculate some values. So I'm gonna, first of all, CA underscore squared. I want to add values to the CA squared. And in order to do this, we use the append function, dot append, and I want to append I squared. Okay, similarly, lim CA dot append, I'm gonna append the function lim CA, and in Python, to call a lim, to create a natural logarithm, you need to use the Numpy library. So I'm going to use numpy dot log, right? Numpy dot log will generate the natural logarithm. Let's add a comment here. np dot log of x will return ln of x. Okay, and then finally 1 over CA, and here I'm gonna 1 over I. Okay, so after running this command, I should be able to generate, so why is it not happy? np.log of I, it should be fine. So after running this loop, I should have 3 lists, CA squared, which contains all the values of CA to the power 2. Ln CA will contain all the values of the natural log of CA, and 1 over CA will contain all the values of 1 over I. So again, think about this logic is it's I will be my counter. Initially, I will be equal to 0.05, and then CA squared dot append. So I'm adding a value of I squared, which is 0.05, to the list CA squared. Second, then it will go to this line, and then I'm adding the value np.log of 0.05 to the list ln CA, and then finally I'm adding the value 1 over 0.05 to the list 1 over CA. Yeah, spelling error here. 1 over CA, and this way we'll generate these 3 lists. Good, so now I have my 3 lists. Now let's move on to generate the subplots, right? Subplots. Okay, so how do you generate subplots in Python? Again, there's sort of a subroutine or a formula to do it. First thing is you're gonna call the function fig, which means create a figure. You're telling Python create a new figure, and you need to give this figure a name or a handle so that you can, add different things to this figure conveniently. I'm gonna call this figure AXS, right? And then this will be equal to PLT. I'm calling the plot library dot subplots. So I'm calling the function subplots in this library, and then you need to give it a number. You need to put in 2 numbers here. So if you want a 2 by 2, you get 2, 2. If you want to create 4 figures horizontally next to each other, you're gonna put 4 by 1, right? If you want to create, 4 figures on top of each other, 1, 4. That's how it is. You're just giving it the number of rows and number of columns for this table in which you're gonna put in the subplots. Good, so this will be your first line. And again, 2, 2 is the dimensions of the table for the subplots, okay? All right, and when counting the subplots, you need to remember that we always start at 0 with Python. So I'm gonna have 4 subplots, right? So in this case, the 4 subplots have locations of, 0, 0, 0, 0, 1, 1, 0, and 1, 1, right? So if you think of a grid, first the top left corner is 0, 0, top right corner is 1, 1, and then you have 0, 1, and 1, 0. And we need these locations so that we can tell Python which plot to insert at which location. Okay, so let's start off with the 0, 0. And again, 0, 0 is your first plot. And in this case, I'm gonna say to generate this plot, I'm gonna write axis square brackets this time, 0, 0. And so you're basically, this is the handle for the plot. And then you're going to tell, so what do you want to do this plot? You tell Python, okay, please insert a plot in this case. So it will be .plt. So in this location, drop this plot. And in this case, we'll have T versus CA. So I'm going to plot concentration versus time in this case. And let's try to give them all different colors. So I'm going to use G and then add this dash to create a line. Sorry, 1 second. There we go. Yes, GA. And when creating subplots, one thing you could use, or one thing which is useful, is to add a label. And we were not going to use it in this lecture, but adding a label is useful if you want to add a legend later on. But for our case, we're going to add a label anyways. Concentration versus time. Okay, and this label is basically the label for this plot, right? So in case you want to add a legend at the bottom, basically a legend is a box showing that the blue line presents this, the red line represents this. So you can always do that. We're going to deal with legends later because it can be a bit tricky to insert in Python. For now, this should be sufficient. Okay, so axis00.plt time CA G label concentration versus time, and then we need to add our x-axis, our y-axis, a bunch of different things. So in this case, let's add our let's label our axes, and then let's add a title to this plot. So to label our axes, similarly, axs00 dot, and when dealing with subplots, sometimes they can be a bit different. However, in this case, for the axis, we're going to put them both in the same command set. And then you're going to say x label equal this, and then this is the command in which you're going to set your x label time in minutes. And again, to add your the labels for your x-axis and your y-axis, you call the handle for the figure, you use the command set, and then you open your bracket, you put in the different attributes of this command. So first thing is x label, second thing will be y label equals, in this case, y label will be concentration in mole per decimeter cubed. So now we have our plot, we have our x label. What else can we do? Let's add a title. Let's add a title. So to add a title, we're going to have axs, again calling the figure handle. So in this case, 0, 0. And to add a title, we're going to use the function, in this case, set underscore title, and then you open your brackets, and then we're going to put the title of concentration versus time. And to avoid having the title and the label in the same thing, I'm just going to change the label to CA versus T, just to avoid having two of the same thing. What other cosmetic things we could do? We could add grid lines. So let's add grid lines. And grid lines are basically, the thin horizontal and vertical lines creates a square grid on your figure. And it's usually good to have them on a subplot because some of these subplots are usually smaller than a general plot. That makes it easier to read. So let's add, so we're gonna axs 0, 0, and to generate grid lines, usually use the command, or usually call the function dot grid. And this function has some attributes. First one is true. So basically true means please add a grid. And then there's a second function called which, and in this case, we're going to use both. So in Python, in which you can add major or minor. If you add measure, you only see the measure grid points at the big marks. So you're going to see a grid point at 50, 100, 150, 200, and the corresponding horizontal ones. If you add minor, you're going to get the measure ones in addition to sub, in subspaces between them as well. So it gives you, I guess, higher accuracy when reading these figures. Good. So this will generate the first figure in the top left corner. Okay, so now we want to generate the rest of the figures. We want to generate, again, going up, CA squared versus time, ln CA versus time, and 1 over CA versus time. So let's generate the rest of these guys. So I guess let's put this is the, let's put a common subplot for CA versus time. Afterwards here, I'm gonna have a subplot for, let's have ln CA versus time. And again, to generate the second subplot, you're gonna use the exact same list, I guess, of commands, except now I'm using a different position. So instead of 0, 0, I'm gonna have 0, 1. So let's type them out for this case. So AXS 0, 1 dot PLT. And again, I'm just gonna copy the exact same logic, but instead of having CA here, I'm gonna have ln CA. So I'm calling on the other list which we generated, T, ln CA. And let's give it a different color. Say it's red. Let's give it a label. Label in this case will be ln CA versus time. All right, so now let's move on to the titles. AXS 01 set. In this case, I'm gonna have X label, still time, right? Minutes, and our Y label will be ln of concentration in mole per decimeter cubed, right? Move on to the line below it. Let's add a title and let's do the grid. So AXS, again, we're looking at the 0, 1 position or the handle. In this case, I'm gonna have a set title of ln concentration versus time. And let's add a grid, AXS 0, 1 dot grid, let's say true, and which let's just call both as well. Good, so we're done with the second subplot. For the third subplot, have subplot for, let's have CA squared versus time. And in this case, I'm just gonna copy this. I'll just change it manually. So in this case, we'll be in position. So we started 0, 0, 0, 1. Let's go 1, 0, 1, 0, 1, 0 in this case. And in this case, I'm not plotting ln CA. I'm plotting the CA squared, which, what did we call it? We call it CA underscore SQ. So let's call it here CA underscore SQ. And I'm going to change the label to CA to the power 2. And I will change this. It will be CA to the power 2. In this case, the units will be mole to the power 2 divided by decimeter to the power 6, right? And our title in this case will be concentration squared versus time. Good. And then let's do our final subplot here. So we're going to have a subplot for 1 over CA versus time. And in this case, I'm just going to copy it as well and just change a position. So in this case, I want to put this figure in position 1, 1. And instead of CA squared, I want to add 1 over CA. This is what we called it. You can call it whatever you want. 1 over CA. So let's have a look. We had green, we had red. Let's make this guy blue. And let's see if violet works. It doesn't work. No, I don't think violet. I think putting a V will give you triangular figure. Yeah, research it and see what other colors you can add, right? I'm blanking. What colors are there anyways? There's red, orange. Yeah, let's add yellow. Here we go. Let's give it a yellow color. And in this case, I'm going to change the label to 1 over CA. And time in minutes, the Y label is 1 over CA. And the units for this will be reverse, right? It will be decimeter cubed per mole. Let's close this bracket here. Let's close this bracket here as well. I forgot to close it. And the title will be 1 over CA, or 1 over concentration versus time. So now we have our 4 plots. We have the function ready. Let's run it and see if we get what we want. Let's give it a try. Okay, so it's not happy about something. 1 over CA list is not callable. So it's not happy about this line. Okay, so what happened here is we forgot to add the append command. So again, when you want to add a value to a list, you always need to add the append to tell Python, hey, stick this figure at the end of this list. If you don't add it, you can't just assign it as in MATLAB where you just, put the location. You need to really use the append command. We fix this, let's run it again and see if it's gonna give us the figure we want. Here we go. But still not happy about something, so it's saying ax00.plt, axis subplot object has no attribute plt, so it's not happy about something here. Let's see what's wrong. Let's try to troubleshoot this. So I have fig axs equals plt dot subplots 2, and then I have xs. Which line is it? It's the first line. Axs dot plt. Okay, yeah. So what's wrong here is when we need to use the command plot, right? So plt is a library. It is not a command. So if you want to plot, if you remember when we went to the top here, when we generated our first plot, we used plt.plot. So similarly here, I need to use plt.plot. So I need to use the plot function, not plt, to generate the figure. And this is a common error usually, using plt instead of plot. So plt is the library, plot is the command. So when you want to plot something, you should always use the command and not call the library. Okay, let's give it a try here. Here we go. So we have our 4 figures in Python. Let's have a look. Take a closer look at these figures. Okay, I mean, you have the plots, you have the axes, but they're all over each other, right? And this is a common issue with Python subplots. So in order to fix this issue with having them all over each other, you need to add a line at the end, call it fig, and fig is basically referring to this figure, and you need to always say type underscore layout brackets. Let's run it, and hopefully by adding this line, it's going to fix this this issue. Here you go. So let's look at this figure. So you have concentration versus time. Everything is labeled. Ln concentration versus time, CA squared, and 1 over concentration. So I have my 4 figures. It's a clean subplot. You can compare them directly. You can see, oh, maybe this is the best fit. This is not a very good fit. Do all of the stuff. and analyze your data, right? This is very common in reaction engineering, or maybe you're doing it in chemistry, but this is a common type of analysis. Okay, so this is the end of this lecture today. Please watch this video, please do this exercise, and then for your homework, what I want you guys to do is I want to replicate this exercise, but for these different data sets, okay? So I have a data set 1, which is minutes and concentration, different numbers, and then data set 2 seconds and concentration, again, different numbers. You're gonna repeat the same thing, but with different numbers. Have the freedom, maybe you don't want to do it 2 by 2, you want to do it 4 by 1, want to put them next to each other. Take some creative freedom with the colors, with the layout, and just practice and try to get competent with this type of approach and with this type of activity. So I'm gonna start recording these lectures and putting them online, and then I'll be having office hours every day from 5 to 7 p.m. So please try them, take your time to try them, and then come to office hours or send me an email if you're having any difficulties. Thank you very much, and I'll see you guys next week.